If humans want to touch the sun, what kind of detector do we need? First, it must be fast enough to not fall into the sun. The maximum speed must be up to 690,000 kilometers. Second, it must withstand high temperature and be able to cross the sun's surface layer of more than 1 million degrees. And Parker's solar sensor has now successfully done all this. The core goal of its mission this time is to investigate the strangest phenomenon of the sun. We know that the surface temperature of the sun is about 5,500 degrees Celsius, but its atmosphere, which is the maximum temperature of the sun's surface layer, is 2 million degrees Celsius. This phenomenon is completely contrary to our common sense. It's like the air around the flame is 100 times hotter than the flame itself. In order to solve this problem that has troubled the scientific community for decades, Parker's solar sensor, which costs $1.5 billion, was launched into space on August 12, 2018, in the Canaveral corner of the United States. It carries a high-capacity particle detector, solar wind electron, and particle detector, latitude and longitude imaging device, electronic field measuring device, and other advanced devices. These devices allow scientists to study the sun at close range for the first time. Many people may wonder why Parker's solar sensor can't melt millions of degrees Celsius a day. The answer to this question has subverted many people's common sense, because high temperature does not equal high heat. The temperature is measured by the speed of the particle heat movement, and the heat depends on how many particles hit you. Because the particles on the sun's surface layer are too rare, Parker's solar sensor does not actually touch so many high-temperature particles. This is like when you take a bath, you can withstand more than 40 degrees of water temperature. But when you take a sauna, you can withstand more than 70 degrees of temperature. Despite this, it still needs to be able to withstand 1,400 degrees Celsius of high temperature. This heat mainly comes from solar radiation. In recent days, its radiation intensity is 500 times that of the Earth's orbit, which is equivalent to being sunburned by 500 suns at the same time. For this purpose, the engineer designed this thermal imaging device full of black technology. This is a shield with a diameter of 2.4 meters and a thickness of only 11.4 centimeters. First of all, its surface is covered with a high-performance white ceramic coating, which has a very high reflectivity. Secondly, the material used for thermal imaging is a very light carbon foam, which is also known as a solid compound material. This material is not afraid of fire, plus 97% vacuum structure, so the heat transmission efficiency is very low. The thermal imaging test done in this way can withstand 1,600 degrees Celsius of high temperature. The internal instrument can also maintain a room temperature of 29 degrees Celsius. But because it is a handheld shield, it means that you have to make sure that the shield is facing the sun all the time. Therefore, Parker installed a 0-meter thermal sensor at the edge of the shadow area of the heat shield. Once it feels the sunlight, it can automatically adjust its posture to ensure that the shield is always facing the sun. Under the continuous acceleration of solar energy, Parker successfully created a distance of only 6.2 million kilometers from the surface of the sun and a relative speed of up to 192 kilometers per second, making it the fastest detector in human history. It is worth mentioning that although this speed is 17 kilometers per second, due to its orbital characteristics, all of Parker's functions are used to maintain the orbit of the sun, so it does not have enough energy to break away from the gravitational pull of the sun. When crossing the sun's surface, Parker discovered the square structure in the solar wind and the continuous magnetic waves. These waves can instantly increase the speed of the solar wind by 480,000 kilometers per hour. In addition, it also observed the underground area of the universe about 5.6 million kilometers away from the Sun. This discovery completely changed our understanding of the environment near the Sun. According to the original plan, Parker's mission period is 7 years. It should be over after completing the 24th recent flight. But due to the good performance of the detector, the mission has been extended to around 2029. This allows it to fully observe the complete cycle of solar activity from extreme low to extreme high and obtain more comprehensive scientific data. It is expected that in 2029, when Parker's detector runs out of chemical fuel, it will not be able to maintain the posture and direction of the protective shield. Then it will fall at high temperature and eventually merge with the Sun.